Hi everyone, let's do another gas stoichiometry question. In this one, be sure to pause this video so you can actually have a look at the question, have a go at it yourself before you do anything with me, and then now let's actually solve it for you this time. Alright, so first and foremost, you're going to need an equation. So we have calcium carbide, which is a solid. So you have calcium carbide, solid, and you react that in liquid water. It produces acetylene gas, C2H2 gas, and calcium hydroxide in solution. Awesome. So here it's slightly unbalanced, so we're going to need to balance it a little bit. So on the left hand side we have one calcium, 2 carbons, 2 carbons. However, our hydrogens and oxygens don't actually match up. If we do match up, let's put a 2 here, and now it should match up because we have 2 oxygens, 4 hydrogens, 1, 2, 3, 4 hydrogens matching up. It is balanced. So now we have 3.25 grams of solid calcium carbide. So let's make that in cadmium orange. So we have the number of moles of our calcium carbide, CaC2, is 3.25 grams divided by the molar mass of calcium carbide, which is about 64.1 grams per mole. That leaves us with the number of moles of calcium carbide is 5.07 by 10 to the negative 2 moles. Now we can compare that to the number of moles of acetylene, and we should actually figure out, and it's pretty obvious in front of us, let's put it in sky, the number of moles of acetylene, C2H2, should be the same as the number of moles of calcium carbide. Beautiful. Now that we know that relationship, we can go ahead and figure out what is the volume of our acetylene. So our volume of our acetylene, C2H2, at STP is going to be the number of moles of it, so 5.07 by 10 to the negative 2 times 22.71 liters, and it gives us a volume of 1.15 liters to 3 significant figures. 1.15 liters. Alright, so now, because we have all that, we need to figure what, this is all at STP, so 1.15 liters is at STP, not SIP, STP. Okay, so now let's actually, let's figure it out. Let's figure out the rest of it. We're going to need to combine gas law. Now we've done a couple of questions already, so I'm not going to tell you what it is. I'm just going to put in the values straight away. Because we're using millimeters of Hg at STP, it's 760 millimeters of Hg is at STP, times the volume, 1.15 liters, STP 273 Kelvin, proportional to, we have 740 millimeters of Hg, so slightly less than 1 atmosphere, times the second volume, which you don't know, and at a little bit higher temperature at 290 Kelvin. So if we rearrange to get V2, it should end up 760 times 1.15 times 290 divided by 273 times 740, which will actually end up giving us about 1.26 liters. And of course, you've got to always address the actual question itself. We want to know how many milliliters, so that's around about 1,260 milliliters. And that is our problem solved.